Assalamualaikum warahmatullahi wabarakatuh. We are from class T5 CS267 to B2 Group 3, and today we will present our mini project entitled Death of Infant. This project is prepared for MAT523. In this presentation, we will explain the data analysis, method used, and the results obtained from our study. Before we begin, let me introduce our team members. First, Muhammad Izul Faris bin Rustan. Second, Azil Shahira binti Makshe. And third, Nur Izzah Atira bin Mahhusin.
Table 1 presents the statistics of infant deaths in Malaysia from 2009 to 2003. The data were collected annually to study the trend in the number of infant death cases over the years. In this investigation, the year is represented by variable X, whereas the number of infant deaths is represented by variable Y. Since the value of Y vary according to the year, several mathematical models can be applied to analyze the relationship between the two variables. In order to obtain the most suitable representation of the data, three different models will be considered, which are the linear model, quadratic model, and cubic model. The comparison of these models will help determine the best fit curve for the given data. As you can see here, this is the statistic of infant death in Malaysia from 2009 to 2023. We listed two variables, which is X and number of infant deaths per year. Next, this slide shows the development of the linear model using the least square method. First, we define the matrix M, whereas the first column consists of ones and the second column represents the values of X from 1 until 15. Besides, it is the vector of observed Y values. Using the normal equation, we calculate M transpose M and M transpose Y, as you can see here. Then, we find the inverse of M transpose M, shown here. After multiplying M transpose M inverse with M transpose Y, we obtain the parameter vector V, which contains the coefficient A and B, as you can see the result. Therefore, the best fit linear equation for data is here. We're using the A plus BX equal to C. Next, the matrix and calculations are used to find the best linear equation that fits the data values. From this model, we calculated the error value, which is shown on the right side. The magnitude of error helps us measure how accurate the model is. A smaller error means the linear model fits the data better. As you can see here, we obtain the magnitude of error of 880.1231840. Next, we already plotted two graphs. First graph is point of scattered data, and second graph is graph of residual. These are the graphs that we have been plotted.
Assalamualaikum. My name is Nur Izzah Atira binti Mahhusin. My part is quadratic model. So, this slide shows the process of forming a quadratic model using the least squares method. The quadratic equation used is y equal to a plus bx plus cx squared. First, the matrix on the left represents the values of x squared, and the observed data values y. These values are arranged into matrix form to make the calculation easier. Next, the matrices M transpose M and M transpose Y are calculated. These matrices are important because they are used to find the unknown constants A, B, and C. After that, the inverse matrix M transpose M inverse is obtained and multiplied with M transpose Y. Finally, the best fit quadratic equation is obtained as y equals to negative 3341 over 476 x squared plus 89899 over 1190 x plus 16161 over 5. In this slide, I calculated the error vector, also known as the residual vector. The residual vector is obtained by subtracting the predicted values from the actual data values, which is M equal y minus mv. Next, I calculated the magnitude of the error vector, which is approximately 755.8 0.8981485. This value measures the overall error of the model. A smaller error magnitude indicates that the quadratic curve fits the data more accurately. In this final slide, the graph on the left shows the scattered data points together with the quadratic best fit curve that was calculated. The curve generally follows the overall pattern of the data, indicating that the quadratic model provides a fairly good approximation of the relationship between the variables. On the right, the residual graph shows the error values distributed around the x-axis, y equals to 0. Ideally, the residuals should be randomly scattered close to 0. Even so, the quadratic model is still useful for representing the general trend of the data.
Before I start, let me introduce myself. My name is Azur Shahira binti Matshe, and I will explain about the cubic model. The cubic model is written as y equals to a plus b times x plus c times x squared plus d times x cubed. We arrange the data into the metric form, where metric m contains the value of x, x squared, and x cubed, while vector y contains the observed data value. Next, we apply the least square method using the formula V equals to M transpose times M in bracket inverse times M transpose times Y to calculate the coefficient A, B, C, and D. After solving the matrix, we obtain the best fit cube equation, which is y is equal to 125,228 over 39 plus 135,017 over 1,512 times x minus 506,789 over 55,692 times x squared plus 4,139 over 47,736 times x cubed. This equation represents the cube curve that best fit the data. Next, we calculated the error vector by subtracting the predicted values from the actual data values. The magnitude of the error vector is approximately 755.61. This value measures the overall difference between the model and the actual data. In this slide, the graph on the left shows the scattered data together with the cubic best fit curve. The data on the right shows the residual error around the x-axis. Since the residuals are distributed around 0, the cubic model gives the reasonable fit for the data.
The conclusion is, based on the investigation, we compared three best fit curve methods, which is linear, linear quadratic, and linear cubic equations. From the results, the linear cubic equation produced the smallest error magnitude, which is 755.6132342. Therefore, it is the most suitable method for this project. This graph shows the linear cubic equation model. The blue curve represents the fit curve, while the red line represents the actual data. The curve follows the data trend quite well, which proves that the linear cubic equation is the best fit for this project.